Good morning, everybody. What will happen if your on-premises Active Directory is breached and this breach is escalating to your cloud environment? Or even worse, if your cloud environment breach escalates back into your Active Directory. In the next 45 minutes, I'm going to discuss how attackers can exploit hybrid identity or control plane trust path to gain access to environments and to move laterally between those environments. Before we get started, I would like to thank our sponsor. Without them, we would not be here today, so a big thank you to all of them. A few words about myself. As you mentioned, I'm Guillaume Bossiroy. I'm a cloud security consultant at Resilix. I'm mainly working with cloud security, offensive and defensive. I'm mainly working on security engineering, implementing security features at customers, but also doing some incident response and offensive security engagements in Azure and hybrid environments. But my main focus lies in Microsoft 365, Azure and Entra-ID security stack, and that's what I will focus today. You can find me on LinkedIn, and also I don't have my own blog, but you can also find I'm posting regularly on the Resilix blog, as my colleagues are also doing. So what are the topics for today? First, we'll have an introduction just to set the basics. Then we'll see 3 scenarios how to attack, detect, and defend. We'll see how attackers can go from on-premises to cloud environment, then from cloud environment to on-premises, and then we'll close the loop by having a scenario that goes from on-premises to cloud and then back to on-premises. Then we'll have a conclusion and hopefully time for Q&A. All right, maybe a bit of background. Why this talk? Why am I here today? As I mentioned, I perform security offensive engagements in cloud and hybrid environments, but I'm also implementing Azure and hybrid security controls in customers' environment. So sometimes I'm trying to break what I'm implementing at customers. One issue, one problem that I identify mainly during my offensive security experience is that some hybrid identity and control plane trust paths are not always covered or are underestimated by blue teams and also red teams. So my goal today is to demonstrate how real-world hybrid private scenarios can be abused by attackers and how you can defend that. We'll have demos, and I will, for each scenario, I will provide some practical defensive guidance for the blue teams to detect those abuses and then to protect against them. To make sure that everyone understands the basics, I just did Entra-ID with Azure 101 slide. What is Entra-ID? Entra-ID is formerly Azure AD. It's a cloud-based identity provider. It can be seen as on-premises Active Directory, while the concept or the principle is the same. The underlying concepts and technologies, protocols are completely different, but it stores users, groups, service principals, etc. During the presentation, I will mention tenant. A tenant is, in fact, a dedicated instance of Entra-ID and often represents an organization. Entra-ID is mainly used for authentication. Then we have Azure. Azure is the Microsoft Cloud Resource Platform. That's where you can deploy applications, where you spin up virtual machines, and so on. And those resources are mainly deployed in subscription, which is a container that will hold those Azure resources. It's also an access, billing, and governance boundary, so one subscription is isolated by default from other subscriptions. I mentioned that Entra-ID is used for authentication. Azure has its own access control model, which is the Azure Airbag model, so the Azure role-based access control model that is used for authorization. So Entra-ID will issue the access token, and then the Azure Airbag roles will be used to validate whether users have access to specific resources. A few security principles in Entra-ID. You have users, can be human users, but it can also be service accounts that have been provisioned as user accounts. Then you have service principals, which are mainly application identities. You have an application that runs in the background and thus needs to access some connected resources in Entra-ID. Then that's typically what you use. And then with managed identities is important for the first scenario. It's a special type of service principal that is assigned to Azure resources. And then you don't have to manage credentials of those managed identities because Microsoft fully managed them, so you don't have to rotate secrets or certificates. All right, maybe just to get an overview, who has working experience with Azure Entra ID in the audience? All right, okay. For the first scenario, which may be the most basic scenario, then we'll go to scenario 2 and 3, which will be more advanced. But we'll see how we can go from on-premises environment to a cloud environment by using a managed identity on an hybrid VM. Before we get started with the scenario detail, just a few concepts. First, we have the Azure Instance Metadata Service. It's a service that runs locally on any cloud virtual machine. And this service is actually exposed on a non-routable IP, which is 169.254.169.254. And it gives information on the current virtual machine. So you can get information about the network and about the resource in Azure. This instance metadata service also can be used to get access tokens from the managed identity, which is assigned to that virtual machine. And those access tokens that you get can then be used to access other Azure services. At the bottom of the slide, you see an animation. So you have an application that runs on an Azure virtual machine. And if that application wants to access Azure resources, it can go to the instance metadata service, which will then told to Entra ID, get back an access token, and that access token can be used to access those resources in Microsoft Azure. How does our first scenario looks like? We have the internal network of an organization, and this internal network has been connected to Azure and AWS virtual networks via site-to-site VPN connections, which is quite frequent in organizational environments. In Microsoft Azure, you can have an Azure virtual machine that is assigned to a managed identity and then can access other resources. That's also a pretty common setup. And in AWS, you have similar setup. Instead, it's an EC2 instance role that is assigned to the EC2 instance, and that role can be assumed to get access to databases in Amazon FDS or storage objects within Amazon S3. If you are an attacker or a red teamer and wants to access those resources and are in the internal network of that enterprise environment, you can potentially try to connect to those virtual machines and assume the identity of that virtual machine and then access to cloud resources. Why I'm talking about this scenario today? Because when doing offensive security engagements, we often have initial foothold in an organization network, internal network, and sometimes we do have some objectives that are cloud-based. So when we access some server, we always check if that instance metadata service can be for Azure, GCP, or AWS is running, and maybe we can abuse that to gain access to cloud resources and further expand our access in the cloud. So I have a first demo to show you how it looks like in practice. So we are on an Azure virtual machine, which is an internal network on that IP. If I want to see if that more information about that virtual machine, I can go to the instance metadata service and get more information about the resource running. So here I see that I'm running in the Azure Public Cloud. I see the VM name, the offer name. I also see the admin username, and also that password authentication is disabled. We see the SSH authorized key. Also, that is something that will be interesting, is that you see the resource ID of that virtual machine running in Azure. So that information can be used then for enumeration later on. Also, you see the network interfaces. For instance, if there's multiple, you will see them all. Here we only see the private IP address. All right, because it's an Azure virtual machine, I can try to request an access token to access the management.azure.com, which is our Azure REST API. So via that Azure REST API, I can take actions, administrative actions in Azure. So here I see that I have a token. When I call that IMDS endpoint, and then I can use that token to list subscription that I have access to. So here we see that I have access to one subscription, which is a Guillaume Lab pay-as-you-go subscription. Okay, so I know that I have access to that subscription. How can I check further what I have access to? Then I can check for the resources I have access to, and there we'll see that an Azure Key Vault is that our managed identity has access to an Azure Key Vault. Because we know that we have access to a Key Vault, we can list the role assignments that we have in that subscription so that we know what we can do inside that Azure Key Vault. Here we see the results of the role assignments. So we see two role assignments, one for the admin user. So it's a human user that is used to manage secret certificates and keys within that Key Vault. And then we have the second role assignment, which is for our managed identity. We see principal type service principal, and the principal ID is our managed identity. And that role is the Key Vault secrets officer. This means that we can manage secrets in Azure Key Vault. All right, so now that I know that, I can go to the Vault. I can request an access token for the vault.azure.net resource, which is the data plane of Azure Key Vault, so that I can do data plane operation like secret get, secret list, in that Key Vault. So we retrieve the access token, also setting some variables for small scripts to list all the secrets that I have access to. So we see that I'm using the Vault endpoint and then /secrets to list all the secrets within that Azure Key Vault. And we'll see that one secret is being returned, which is a BTG account password. So it's a break the glass account password, which is highly privileged account in Entra ID used for recovery purposes, and then I can go to that endpoint using the Key Vault token that I got before to get the password of that account or the content of that secret. We see that the content is this is a BTG account password. All right, so why were we able to list those resources or that resource and the role assignment? In fact, it depends on the role that the managed identity has been assigned to. In this case, it was assigned to the Key Vault secret officer role, which as you can see at the bottom of the slide, which has a get role assignment permission, and that permission allows you to list resources and the related assignments, role assignments on that resource. However, if we take another one, like the storage blob data contributor, we see at the bottom of the slides that the get role assignment is not listed. So we could have access, actually this managed identity was assigned the storage blob data contributor to a storage account, but we did not see it, nor the role assignments when querying the API. So this is something you can also take into account if you're a red teamer, want to access some cloud resources from cloud virtual machines. Always make sure that you do not stop with what you can see. There might be services or automation that then reach out to that service, to that storage account, and that you can also abuse or retrieve sensitive information. All right, so that was the more attack part. Now let's go to the detect. How can you detect such abuse? It's usually not done in most environments because it can be difficult. You need to have detections for every use cases, but it's an approach to at least get detection rules for the most sensitive resources in an environment. So first is look for uncommon Key Vault operations or any other operations. Here we see that secret list has been performed, while if an automation knows which secret to access, it does not probably need to do secret list, but only secret get. So that secret list can be seen as suspicious and then trigger some alerting. Then you can also check for different IP addresses, for unexpected IP addresses. If your automation is running from a private IP and contacting your storage account privately using a private endpoint, so one-to-one connectivity, you should not see public IP addresses or different IP addresses accessing that Key Vault. And also here we see that the list container operation has been done. Again, if you have an automation running, it probably does not need to list resources because it knows what to access. Finally, how can you protect? Block public access to Azure PaaS resources. So what are PaaS resources? It can be storage accounts, it can be Key Vaults, SQL servers, and favor connectivity over private endpoints, so one-to-one communication connectivity. We do not see that often in customers' environment, enterprise environments, because private endpoint will incur cost, but then you can still use firewall rules to allow list which IP addresses, public IP addresses you want to allow to access your resources, and this will already allow to decrease the attack surface of your resources. Then we have follow the least privilege principle. I will mention it a few times during the presentation, but if we would have assigned the Azure airbag role at the secret level instead at the key vault level, all of this would not have been possible. We would not have seen that Azure key vault and the role assignment. And finally, we have Enter-ID protection, which is a premium feature in Enter-ID, which allows to detect suspicious usage patterns for workload identities, including managed identities. All right, so that's the first scenario. Now, for the second scenario, we saw how we can go from potentially on-premises to cloud. Now, how can we go to cloud, from a cloud environment to on-premises? And this will be by abusing Azure Arc. You may ask, what is Azure Arc? Azure Arc is a multi-cloud and on-premises management platform which extends the Azure control plane by projecting non-Azure or on-premises resources into Azure Resource Manager. And you will see those resources in Azure as if they were running in Azure. It can be used for SQL servers, Kubernetes clusters, and also servers, Windows and Linux. In our case, we'll focus on those. When you Arc enable a server, it's called an Azure Arc enable server, there will be the Azure Connected Machine agent running on that server, and then this agent will do first the communication back to Azure, and then it will also allow also define what is allowed to run from the Azure control plane on that server, but we'll come to that a bit later. We also see Azure Arc being more and more used at customers because it's a requirement for some services like Defender for Server, which is Microsoft Defender for Endpoint on Linux and Windows servers, and also for centralized logging if you want to collect security logs from on-premises servers, for instance. You can. One option is to install Azure Arc and the Azure Monitoring Agent to then collect the logs in the Microsoft SIEM solution, which is Microsoft Sentinel. So this is more and more used because of those requirements. Also good to know is that those Azure Arc-enabled servers also have their instance metadata service running, and every Azure Arc-enabled server is by default assigned to managed identity. By default, it does not have a lot of permission, but it can be used to grant permission so that an SQL server can access, a server can access an SQL server in the cloud. You can also get tokens for that. The instance metadata service is running on the local host port 40342. The process is similar, except that you just need to prove that you can access a secret file and then pass the content of that secret file when you request an access token. And once you have the access token, then you can access Azure resources if the Azure Airbag allows it. It's also interesting, Azure Arc is also interesting because it provides very powerful control plane capabilities. For instance, you can run commands or execute arbitrary scripts via the custom script extension as system or root on Linux, so anti-authority system on Windows or root on Linux. And for instance, if you take the example of the custom script extension, it can be abused for command and control. Let's say during a red team engagement, you compromised a server of a customer, you can potentially onboard that server to Azure Arc into your Azure Control subscription, and then send scripts via that Azure Arc agent to that on-premises server. I'm not sure if I would do it, but it's then you abuse a trusted service on those machines, at least on Windows servers. To be able to run those commands or execute scripts, you need to be admin, to have owner permission or contributor permission on those Azure Arc objects. All right, so how does the second scenario looks like? Again, we have the internal network of an organization, and in their environment, they have on-premises servers. And because they want to centrally manage those servers in Azure, do patch management, collect security logs, they decided to onboard it to Azure Arc. And because of that, then they also decided to use a managed identity to access other Azure resources via that managed identity, as we've seen in scenario 1. What if someone has malicious intent, an Azure admin with malicious intent, or someone could compromise an administrator in that subscription? They could potentially connect to that server and execute commands as anti-authority system on your on-premises server. How does it look like in practice? Hope it's big enough. So first, we are on the DC01. Guillaume lab.local, so that's my main data domain controller in my AD environment, and we see that Azure Arc is running on that machine, on that DC. So if we check the object in Azure, we see that we can get some information about it. You see the domain FQDN, you see the machine name, you also see hardware information, the network interfaces, and so on. Because I'm owner, or at least I do have administrative permission on that object, I can go to the Azure API, Azure REST API, and run commands on that server. So the name of the command that you see here, host name, for instance, can be anything, but then the script is what is actually going to run on that server. So in this case, I'm going to run host name and a second command, which will be UMI, just to prove that we have an anti-authority system on that machine for demo purposes. All right, so that's the second command. And after a while, you will get the results from those commands. You see the script has execution completed. You see output DC1 for the hostname command. And then for UMI, you will see that you are indeed running as anti-authority system. Now, a bit more interesting, the custom script extension, as I mentioned, it allows to run arbitrary scripts on the systems, and this can potentially lead to domain compromise. Let's say I'm running Azure Arc, I use the default configuration of Azure Arc on the domain controllers. This could allow me to add users and change group memberships from the Azure control plane. So we are still on that same server. I'm just going to show you that I do have a few users in that domain with the Azure admin and then mostly the built-in users in Active Directory. If I go back to the Azure control plane and the extension page, we see mde.windows, which is the MDE extension for Microsoft Defender for endpoint, and we have the Azure monitoring agent, which will be used to collect the logs. But what if I want to execute script? I can create a custom script extension for Windows. Here I will select the script that I want to run, so the cse.ps1 script. And once the script has executed, which takes a bit of time, we will see that the BSIDES user has been added to our AD domain, to our Active Directory, and that this user has been granted a domain admin privileges. How does it look like? What are the artifacts on the server? If you go to C packages plugins, you will see folders for every extensions that are running on those servers. For the run command, we see that the hostname and UMI commands are visible locally on the server, so we see what has been executed. And then for the custom script extension, you also see, like for the run command, you will see that we can also retrieve the content of the CSC script, which is that one. We see that new AD user, BSIDES, we see the password that has been added, and also that it has been added to the domain admin group. All right, how can we detect those abuse, those Azure Arc abuse? So when I was looking into that, first I was, okay, it's nice to abuse, but how can we detect that? First, I had a look at the Azure activity logs, which were not really useful because of the lack of context. For the run command, for instance, you see that 2 commands have been executed, but you don't see what has been executed. You only see that something has happened. If there would be someone with malicious intent in your environment, they could make it look like it's a legitimate Microsoft service executing those commands. Same for the custom script extension. We see that the custom script extension has been created, but you don't see what has been executed or what was the output of the script. However, if you go to the Azure Arc object, go to the activity logs, and then for every log entry, you will get the change history, and in that change history, you get more valuable insights on what has been done. So on the left, you see the run command hostname, and at the bottom left, you see the script that has been actually executed on those servers. And on the right, you see a bit less information. You see that the custom script extension has been deployed, that we already know, but you can also get the output of the script that has been done, so the get AD group member, and we see that the BSIDES user is indeed a member of the domain admin group. That's why I mentioned that it can be interesting for command and control, because then you can execute script and get the output of those scripts in that page, in that dashboard. How can you protect against those? The first step, the first recommendation I have to customers is to always prevent command and script executions. Use an extension allow list to make sure that you only allow what you want to run on your server. If you only want to collect logs, then only allow that specific extension. Or if you cannot use an allow list, you can use the Azure Arc Agent Monitor mode, which will allow Microsoft Defender for server, log collection, and so on. I do have a note, though, on Microsoft Defender for endpoint part. If you install Microsoft Defender for endpoint and that the server is onboarded to your MD tenant, then you will also get the possibility to do a live response session on those servers, and that can be used also for script or command executions from then the Defender portal, but then from a cloud control plane. So that's also something to be careful of. So the main key takeaway is to disable all unnecessary capabilities. Azure Policy, Windows Admin Center, the custom script extension, and the run commands can all change the configuration of your servers from the Azure control plane, which increases the attack surface of your on-premises servers. Then use the least privilege principle for the onboarding service principle. It's not something that I tackle now because it's because of time, but if you are in enterprise environments, we see that a lot of customers are using group policy objects to deploy and to onboard servers to Azure Arc. And those credentials of the service onboarding service principal can be easily extracted from on-premises, so make sure that you limit the permissions to the minimum required, which is Azure Connected Machine onboarding role. If you give admin access, the connected machine admin role to the service principal, then it can be used to execute commands and scripts again on those servers. And then, as we've seen during the first scenario, monitor for managed identity misuse. All right, so this brings us to our last scenario from Active Directory to cloud and then back to a different Active Directory domain by abusing delegated administration. I think it's pretty interesting example or demo, because that's what we've encountered during a red team at a customer. We compromised their AD environment. We were able then to move to their cloud environment, and from that we also saw that their environment was connected to customers' environment, and from that connection we could also use Azure Arc, as we've seen in scenario 2, to gain access to their on-premises server. So it can be seen as a kind of a supply chain compromise by abusing identity first path. All right, a bit of concepts first. So in this demo, I will discuss about Entra ID Connect, which is an agent that you can install on your on-premises Active Directory to synchronize identities from on-premises to Active Directory. And this will sync users, devices, groups, and group membership, potentially, if you enable that. And while it can be useful for centrally managing your identities, it can also have some security implications. What if your privileged identities are synced from Active Directory to Entra ID? This could potentially lead also to a full cloud compromise if your AD is compromised. If you have global admins that are synchronized from your on-premises Active Directory, then attackers could leverage that connection, that trust, to gain full access to your Entra ID tenant. And then we have Azure Lighthouse. Azure Lighthouse is a feature that enables cross-tenant Azure management by allowing delegated access to subscription from service providers or multi-tenant enterprises environment. And this, as we see at the bottom of the slides, we have the service provider tenant with the Azure Lighthouse. That service provider tenant will define a Lighthouse template, which defines the permission and the role assignments. And then on the right, we have the customers tenant, and those customers tenant will deploy the template to delegate access to their own resources to that service provider tenant. It's commonly used in by a managed security service provider or also SOC team to gain access to Microsoft Sentinel workspaces from customers. Once they've deployed that Azure Lighthouse, the customers have deployed that Azure Lighthouse template, they can get, the service provider will get delegate access to those Azure resources, and from that service provider tenant, they will have a centralized view on all those resources. They do not need to use guest accounts. They can access that as if the resources were deployed in their own tenant. So as I mentioned, a template is defined on the managing tenant side, and then the template is deployed in a managed tenant by a non-guest account in the managed tenant by an account that has owner rights. During testing, Stefan and I discovered a vulnerability that could allow any user, even guest users, to do the onboarding of that Lighthouse template. So a guest user can delegate access from one subscription of their customers potentially to their service provider tenant. So we decided to report this vulnerability to Microsoft, which decided to fix the documentation. So it's not a non-guest users, it can be any account if they have the correct permissions. But I think this is quite interesting because if you have owners in your subscriptions and that they have owner permission for some reasons, then they could use that access to delegate some of your resources to their tenant without you knowing, and I'm going to come back on that in the next few slides. So how does our third scenario looks like? We have a managed security service provider, which is my AD domain, so the guillaumelab.local AD environment, and that Active Directory is connected to my guillaumelab.onmicrosoft.com Entra tenant, and of which there is one synced AD group that has privileged access, admin access to Azure Lighthouse delegations from my customers. Then we have the Resilix environment, the Resilix lab environment, which is the customer tenant. We have the AD local with the AD SRV1 domain controllers, which is an on-premises server, of course. And then this server is also onboarded to Azure Arc for management purposes, to collect the logs and for the deployment of Defender, for instance. And as I mentioned, the Azure admins will get access, contributor access to the subscriptions in the Resilix lab.onmicrosoft tenant. But what if someone compromised the MSSP AD environment? Then they can add themselves to the SIG AD group, and then they can get admin access to the customers' subscriptions, Azure environment, but also Azure Arc objects if they use the default configuration. This is last demo for today. It's actually how it went, or the scenario went when we were working on the engagement. It's a bit simplified for demo purposes, and the context is changed, of course, but this is exactly how it went. So we are on a standard workstation of a user named user, to make it easy. That's in my Guillaume lab, the local AD domain. I'm on standard user workstation, which has been hybrid Azure AD joined, and SSO is not enabled in that case, but we can imagine that SSO single sign-on would be enabled in hybrid environment to allow users to use their on-premises identity to connect then to cloud resources without to have and to enter their credentials again. Eventually, we were doing some reconnaissance, and we discovered that there were a few groups that were hinting that they could give access to Azure. So that was interesting. We decided to check, okay, what do we have access in Azure at the moment? And then we didn't see any resources, any subscription. We also were only in the guillaumelab.onmicrosoft .com tenant, so nothing special. Eventually, we found a vulnerability by enumerating the ADCS, Active Directory Certificate Service templates, and we found an AC1 vulnerability, which is one of the most common Active Directory misconfiguration nowadays. And this misconfiguration allows any user in that AD domain to request a certificate for any user. So in this case, we requested a token, a certificate for the built-in domain admin, because why not? So here we have the certificate of that domain admin, and using another tool, we'll ask a TGT, so a ticket, it can be seen an access token, for that built-in admin, and inject it in our session so that we can manipulate group memberships. So in this case, yeah, we added our user into the Azure admins group. And just to validate that we have access, that we have been successfully added, we can do the get AD group member, and we'll see that there is 2 users, the Azure admin and the user. After refreshing our access in Azure, we see that we have no access to a new subscription, which is a BSIDES customer demo pay-as-you-go subscription. That subscription is in fact the subscription of the Resilix Lab tenant, and you can see that by the tenant management group ID, which is the tenant ID of that Resilix Lab on Microsoft tenant. And then you also see that we have a server. It's maybe going a bit fast, but there is an on-prem server that is ARC-enabled. And because I am admin contributor access to that subscription, I can also execute commands on that server. I will run 2 commands. First, to get domain, to get the domain of that machine, just to prove that I have access, and then the hostname command, also for demo purposes, to show that we have access to that server. All right, after some time, we'll see that the domain is indeed ad.local, so the AD environment of our customer, and then we see that the host name is AD-SRV1. All right, then how does it look like in the background? I thought it would be interesting for you to also see what is configured in the background. First, we have the Azure admin, so we are in the managing tenant. We have the Azure admin group in Entra, which is a group that has been synced from their on-premises Active Directory, and we see our 2 users, of which our user named user that we have been adding via AC1 abuse. Then we see indeed that we have a customer, which is Resilix Lab tenant, and then we see that our BSIDES customer demo pay-as-you-go subscription has been delegated to the Azure admin group. And we see that the contributor and user access admin permission has been delegated. On the other side, we have the delegate tenant, the managed tenant, so the Resilix Lab.on-Microsoft tenant. We see the subscription that is part of that tenant. And if we go to the role assignments in that subscription, we only see one for the owner of the subscription that has been assigned when creating the subscription. You do not see Azure Lighthouse permissions that have been delegated via Azure Lighthouse. You only see that in the dashboard of Azure Lighthouse. There you see that there is indeed a delegation for the subscription to Azure admins with the contributor and user access admin. And you do not see what is Azure admins. It could be a group, it could be a user, and you don't know how it's managed on that end. So that's why I mentioned that it's quite interesting because you can add permission in a stealth way, because not a lot of companies are constantly looking or even monitoring Azure Lighthouse deployments, so that can be quite stealthy because permissions are not shown in Azure portal access control page of a subscription. Okay, we can. How can we detect that? We can detect ADCS abuse. In this case, AC1. On the left, you see that the certificate has been requested by the user for the built-in domain admin account, so that should trigger detection. And then you also see that following that event, the domain admin has authenticated using certificate-based authentication. So if that's not something you use for your built-in domain admin, or it should not be used, but if that's something that is not used, that should also trigger detection. I also had Microsoft Defender for Identity running on that AD environment, a Microsoft Defender for Identity is an on-premises security solution that will monitor activities that happens on premises. And I had two alerts, two incidents generated, one for certificate enumeration and then one for the certificate-based authentication attempt for the domain admin. However, group membership changes is not something that is monitored or often monitored by organization. We've actually never been caught changing group memberships. A funny example was that an organization, they were monitoring, they had alerts for group membership, sensitive group membership changes, but those alerts were sent to the mailbox of an admin that was only checked once a month. So by the time we were done, they only caught us. So yeah, once you get domain admin, changing those sensitive groups that are synced then to to Entra ID is something that is not usually monitored, and that it's maybe more difficult to monitor. How can you defend? How can you protect? First step is to avoid synchronizing privileged identities or groups from on-premises AD that would grant elevated Azure or Entra permission. Make sure that those are cloud only. For users, for admin users in Entra, they should be cloud-only dedicated account and named account, not shared account. And then groups should be, groups that grant privilege roles should be also managed in Entra only and not synced from AD, because otherwise this trust relationship can be abused. Then also, it's not really the scope of that presentation, but make sure to audit and harden your ADCS configuration. As I mentioned, it's one of the most common AD vulnerability nowadays. So if you have that running in your environment, make sure to run an audit for that. Follow the least privilege principle. It's the third time I'm telling that to you now. But make sure that you follow it everywhere you can in Azure and everywhere else, because it can prevent most of abuses or exploits in Azure or cloud environment. And then finally, as I mentioned, monitor for Azure Lighthouse deployments. If you do not use Azure Lighthouse, seeing those activities in the Azure activity log should be highly suspicious, and especially if you have a service provider or owners in your environment that have elevated access. All right, so for the conclusion, nothing was really new. It was not a 0 day. It was also not a misconfiguration in isolation. It's more a chaining misconfiguration and abusing legitimate services that are actually used in customers' environment. So it's made to highlight that while those services can be used, and I've heard some people saying that do not use Azure Arc, it will just expand or increase your attack surface on premises servers. I do not completely agree, because it can be used for legitimate reasons, but then make sure that you harden the configuration of the agent. Do not run it in the default mode, which is a full mode, which allows all the capabilities, because control plane access can translate into system or root level access execution on those hybrid machines. So yeah, to link back to the title of the presentation, make sure that you audit also those identity breaches. I think all abuses related to Entra ID Connect are well known. ADFS abuse are all well known, but those are usually, from what I've seen, less monitored or less tackled by organization. What are the main key takeaways of this presentation? That's all the recommendations I've been mentioning during the presentation. So harden the Azure Arc configuration, least privilege principle again, restrict network access when you can, then use dedicated cloud-only users for admin access or admin task, and then use Entra ID groups for granting privileged access in a cloud environment or any applications.